Hello, good evening, all of you. This is our 14th Statistical Saturday Club meet, and as we have committed, we are trying to meet on every Saturday. But because of my some of the preoccupations last 2 weeks, we have been not able to do that. But now I'm releasing this is the recorded session. Earlier I have recorded one, but after 1 hour I got to know after completing whole recording that audio has been not recorded. So that was very disappointing moment for me, but let it be. This happens. So I hope that now at least now audio has been getting recorded. So now this is our 14th Statistical Saturday Club meet, and I'll just share agenda. Yes. So now this is the agenda for us. Actually, it was planned on 2nd of the March. So the agenda is that we will take a short recap of what we have covered so far. Mainly last week we have seen, last week means in the last session, we have seen that what are the two important discrete probability distributions. Like we have seen the normal, discrete normal, sorry, discrete uniform distribution, and then we have seen the binomial distribution. Then we will see some two more important distributions in the probability theory, the Poisson distribution, and there is one more called the normal distribution. So Poisson distribution is a discrete probability distribution, and we will go to the now continuous arena of the normal distribution. Then we will see some Excel practicals that how we can implement this whole part. Okay, so this is our agenda for today's session, and I hope that you will enjoy this along with me. This is the recap. Okay, so to give you the whole picture, see, many of us knows what is probability theory. They knows many formulas, and but the problem is that how to implement those formulas. And implementing, by what I mean that you need to have the understanding that why that formula is being used, what is the actual use of that formula, and why it is being used. So the whole purpose of this our lecture is that you will get the understanding from ground up. Here the formulas are not important. Here the concepts are important. Here why you want to use those concepts, where it is going to help you in the field, in the real life example. That is what the important, and that is what I want you to give the importance to. Okay, so today, yes, so today we will start with our recap with two more distributions: discrete normal distribution. Sorry, here I have wrong. This is discrete uniform. So this is discrete uniform distribution because there is continuous uniform distribution also exists. So this is our discrete uniform distribution, and then we will see the binomial distribution. But before going into that, I will just give a short recap since the beginning until here to the probability distribution, how we have reached. So we have started with some probability theory, and we say that the probability theory is important for us because based on the historical data we can predict that what is going to happen in the future. Not 100% sure, but with some level of uncertainty we can at least suggest that there is a high possibility of happening something, and there is low possibility of happening another thing. Although we cannot predict the future, we can have just a glimpse of or sense of what is going to happen. So that's what the inferential statistics we are studying. So what we have said that we have studied the four axioms of the probability theory. You know all of those. Then we have moved into the some conditional probability. So we have seen the law of total probability, and we have seen the law of Bayes theorem, or Bayes theorem we have seen. So these were mainly under the controlled unit we have seen. We have seen some toy examples like throwing a die, tossing a coin. So these were the examples where we know what are the already, what is going to be the experiment, what we are doing the experiment, what is the outcome, and we know whole sample space. What are the probable outcomes of those all the experiments. But now we are moving into the arena and we want to deal with arena where we don't know what are all the possible outcomes, and even we don't have time to enumerate all the possible outcomes and then do some calculations. So like if I ask you that, suppose now here you have seen the binomial distribution. Here the experiment goes something different. Like if you take a coin toss, I'm just changing the example. Now see how critical it is. I am tossing a coin for 1,000 times. I'm not tossing coin once, 2 times. If I toss a coin for 1 or 2 times, you exactly know that what is the probability of getting head, that is 1.2, or 1 by 2, that is half, or the tail, which is 1 by 2 again. But what if I toss a coin for 1,000 times and I want to know the probability of getting only 10 times head? These are the examples are important. Like you might implement this is my toy example, which you cannot do simply by hands. You cannot enumerate all 1,000 times what is the probability. Then also you cannot do it for, suppose, the example of death in the livestock style. If you register 1,000 animals, what is the probability that only 10 animal will die? Okay, so these are some broader level, big level implications which cannot be simply done using the probability axioms. We need to build further. We need more tools, and that's how we started. Looked at the three more important concepts. First one, we have seen that the random variable, random variable. So what we have seen at a random variable, this is what the data collection part. So if I collect some data, and the more importantly the data is in numerical form, then we will see that it is a random variable. What is the examples of random variable? Random variable can be the gender, male, female, other. We can enumerate as 0, 1 and 2. Okay. Or the random variable can be the age, random variable can be the your height, random variable can be the annual income or monthly income. So these are all the random variables. So if you imagine your survey, whatever sample survey you might have did in your previous work, the all the columns here we are saying that these are the random variables. Not all. The name cannot be the random variable because we are not able going to translate it into the numerical form. That is the only variable. But the random variable is one which we can convert into the numerical form with some good um, insights or the outputs. Okay. The second part we have seen is that the PMF or PDF. So what is PMF or PDF? The PMF is that what we have seen, that probability mass function. And this is what is about the probability distribution. Here we will come. What is probability mass function? Probability mass function will enumerate what are all the possible values the variable will take with its probability. So we have seen one random variable, that male, female and other. In case of gender, it will enumerate, it will give the number of, if you insert the male, or here we take 1, 2 and 3. If we give the input 1, it will calculate the probability of taking this value in the real life. This is what we are interested in. Okay, because see, once you get the formula or you get the function, okay, once you got the function of getting something value and its output as getting something else, this is what the formula of uniform distribution. So you need not to know that what are these all possible values, because suppose there are some values 1 to 1000, there are 1000 possible outcomes. How you are going to enumerate all? Rather than I will take that there is f of x is equal to 1 by n. Now I got simply this function and I can plug it and I can make use of this function to know any kind of analysis, any kind of inferences about the population. So I hope that I'm making you clear about the what is the need of the probability distributions. Okay, so now last time we have seen what is probability distribution. The another definition which I want to emphasize here is that if you see naturally there are some patterns. Okay, here we are seeing that there are some patterns in the nature. We are identifying those patterns, and based on that patterns we are saying that this is going to happen. Like one pattern which has been observed, it is that after every 100 years there is one great pandemic. This is what has been said. Yes, like in 1970s or 20s there was a great Mexican flu, Spanish flu, and now in 2020 there was COVID. Okay, before also there were some pandemics. So this is what the pattern, and then based on this pattern, some people have made some equation to know that whether this year there will be pandemic or not, right? So this is the implementation of the distribution. So once you know that how it is getting distributed, you will fit the formula and you will calculate the probability of getting the pandemic in 1925, 1950s, 1960s, 1970s, and so on. So what we are interested in that there are some patterns already defined. You need not to go and search for those patterns. Those patterns are already defined. We will study those patterns and we will see that if any random phenomena is matching with that pattern, then we will apply that so that we will easily get our answers. I hope that now I have made that what is the use of this distribution, the probability distributions. So now we will first take a look at what is the discrete uniform distribution. Discrete uniform distribution is that the probability of taking x is equal to x is 1 by n. What does it mean? That last time we have seen it very detailed. We will just see that suppose there is the random variable called coin toss. So taking the h is probability is 1 by 2, tail is 1 by 2. This is what, because you know. Okay, but what I know that now I don't need to know this h or tail. So here I have mapped the h as a 0, tail as a 1. Then this becomes my random variable. Now I guess that what is the probability of 0. Without looking at this table, I would say that what are the possible outcomes? There are possible outcomes only 0 and 1. So there are possible outcomes is equal to the n is 2. So it is 1 by 2. What is probability of 1? Probability of 1 is equal to again 1 by 2. Okay, so you got my point. This is the uniform distribution. Very simple. The first one is the very simple distribution. And now we want to move into the little bit tricky, little bit difficult to understand, also some difficult formula, but very useful random variable called the binomial distribution. What is that? The binomial distribution. So what is this? The binomial distribution is very easy. It has been evolved by the Bernoulli. So I just no need to remember names and etc. There is one famous statistician called Jacob Bernoulli. Just what the what is the experiment of the binomial distribution, that I will tell you first. So a person said that if there is experiment which has only two possible outcomes, okay, any experiment if you take, suppose I will say that there are only, suppose for my now question as assumption, there are only two genders possible in this nature. There are male and female. Then that becomes my uh, Bernoulli random variable because it has only two possible outcomes. Or we say that there are only two possible situations of the any person, either alive or dead. So this is my experiment to check the name and ask that the person is alive or dead. So this becomes my Bernoulli random variable because I'm checking what is my question status. What values it can take? It can take only two values, alive or dead. So any kind of more importantly, you have some questions in your sample survey. Answers only have two options, yes or no. Like whether you have taken the two uh, corona vaccines. Okay, so there are only two options. Yes, either you have you are vaccinated, or no, you are not vaccinated. So that becomes my Bernoulli random variable, which we can model by the binomial distribution. Okay, so what last time we have seen that the binomial distribution has formula probability of x is equal to n choose x. So we used to write like this, n choose x. No problem, even if you write below. There are some different notations different times, but this is what we have chosen. But this is also okay. We want to know the only meaning. N choose x, p to the power x into 1 minus p to the power n minus x. How this formula has arrived? What is the use of this formula? See, binomial distribution tells you if you have random variables such like this, alive and dead, and you have calculated already the probability of those two uh, values, like probability of alive and probability of dead, you already know, then in that case you can calculate the probability of alive and dead. Like what are the normal questions which are there in probability distribution? Suppose you have went for the study, you have come across some you are doing study on corona vaccination. So you have question in your questionnaire that what is the, have you taken the vaccination or not? So on India, you know that there are, this is the data that 59% of population got two doses of the vaccine. This is hypothetical data. I don't know exact what is the data, but suppose you know that there are, suppose 60% people have vaccinated for the coronavirus and 40% are not. Okay, so now you want to ask that if I randomly select 10 peoples from a village, what is the probability that the three people, exactly three, not I'm saying less than or more than, exactly three people will be vaccinated? So in case, this is more importantly the implemented practically, means in the case of the companies want to minimize their defects in the products. Suppose there is manufacturing company of say computer or mobile, let's see Android mobile, and they are producing some 1,000 mobiles per day. They want that each and every mobile should be without defects. So they want to calculate that what is the probability that getting one mobile, exactly one mobile out of this 1,000, one mobile defected, and they want this probability to be very near or exactly zero, because as it is very close to the zero, there is very less possibility that they will get defected product. Okay, because they want to keep their quality extra. In case of modeling your, you want to make the insurance product in terms of our development sector. If you want to have some insurance product, in that case you want to know what is the probability of happening exactly the 30 dates, what is the probability of exactly 40 dates, or accidents, 40 accidents, so that you will calculate that what is the premium you are going to charge. Okay, so here the formula is that n choose r, or you can say the x, n choose x, p to the power x 1 minus p to the power n minus x. And how this formula, we will plug just value and we will test. Suppose you have tossed three coins, okay, and you want to know that what is the probability that you will get exactly two heads. Suppose you don't know this function, in that case you need to do all by hands, like all h, sample space will be h, 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 all h, then you will be h, t, h. So that becomes very messy, that you need to 2 to the power 3, so there at least 8 outcomes will be there, and all these things you need to do. So that will take much more time. Then you will calculate where there is exactly 2 h are there. So here there is not exactly h, so there is h. So you will calculate that this is 2h, so this is my favorable outcome. So out of 8, how many are there, and you will get the answer. But if I ask you that I am going to do this for 1000 times, then what is the probability that I will get the exactly two heads? So that becomes very difficult to calculate by hand. But here they have used the technique that will help us. So here what we need to know, so we want to know that what is the probability of success. That is the only variable in this. If you see here, see n is your fixed. Okay, n also you want to know. So you want to know that how many total your outcomes. So you want to know three things here: your n, that means total possible outcomes, sorry, total number of trials; x, the number of successes which you want; the probability of success, that is p. These three things only you want to know. After knowing these three things, you can just plug the values and you will get. So what is our n here? Number of trials 3, because we are tossing a coin for 3 times. What is my x or r or anything? This is just, you need to remember that this is number of successes, which is 2. And what is my probability of getting success, which is, now I have defined h as a success is 1 by 2. Okay, so I can plug these values here. So now it will become 3 choose 2. My p is 1 by 2, 1 by 2 to the power, I want successes 2, so 2 into 1 minus 1 by 2, it's again 1 by 2, 1 by 2 raised to the power n minus 2, 2 minus 1, n is my 3, my success is x, so I will get 1. Okay, and if you do this calculation, you know that how to do this 3 choose by, this is 3 factorial and divided by 2 factorial into 1 factorial. So this is what you will get. Okay, so you can simply just plug the values, and you will know that how you can solve this as a important. Just give me a minute. Yes. So here then what we can give to is that we can calculate this. I will show you that how you can calculate this using the Excel. So no need to do this complex things. But if you know that how to do that, you can do it very easily in the Excel part. Okay, and this is what we have covered last session, and now we will move to the next session, next concept. So which now we will cover. So we will cover two more distributions. So Poisson distribution. Some one like the statistician whose last name was Poisson. So he has discovered that if you take some examples of, there is some frequency, like if you check that number of peoples coming to the railway station, okay, or the number of rainfalls happening in a year. These are some kind of frequencies. Okay, if you take the data on this and then you do some calculations, he has found that there is one certain pattern in this distribution. So by calculating that pattern, he come to know that if you plug this formula, you are able to approximately get nearby to the uh, very near to the exact situation. So you can start the predicting that. So what is that? That we will see. So that any use cases, like here it has been given, like predicting the number of defects in the production batch. Okay, or in the case of insurance, it is estimating number of claims filled in the given month. So next month how many claims will I get? Or in the biology, the number of mutations. You might know that the coronavirus got mutated and another variant come into the picture, and suddenly the number of cases started increasing. So here they can use that model, that number of mutations will occur in our cells in biology. So, or in the traffic, number of car accident. So these are some good examples, use cases where we can use the Poisson distribution. So now, yes, so there is probability of events occurring with a fixed interval. Okay, so there are this, the if you want to model something, your data with Poisson distribution, then you need to look at these three things. The first thing is that the events, whatever events you are happening, should be the rare, like rainfall, the floods, or any other thing. The events are independent. Suppose if I take the event, I am a business entity, and I am getting always the customers. So every hour, on an average, I am getting 5 customers. So I want to model, optimize my services, because I need to keep the tables. I want to minimize the number of tables, so that at any point if customer comes, there should be the table available, so that how many tables I should set up. Like in this case, the events are independent, means first customer coming is not dependent on second customer. Okay, so if you, because of first customer came, there is no other possibility of on another customer, and the rate is constant. Rate is constant. This is assumption that it is not going to change at sudden points. Okay, suddenly there is not going to up and down, so it should not be volatile. Okay, and the use cases I have shared already. In this case, you can model your data as Poisson distribution. So we will see. This is the Poisson distribution formula. You will see many new numbers, like here it is lambda. This is called as the lambda. This is factorial symbol, which you have seen already. Then this is E, first important. This is called as the Euler's number, a very interesting constant like pi. You might have seen up to your high school level. Pi is very important constant in geometry. Like that, there is one another important constant called the Euler's number. And it is very interesting. You please go and search about the Euler's constant if you are interested in the mathematics or any other, like finance also. It is much more used. Actually, if you know the calculus, the limit of 1 plus 1 divided by n raised to n. So that is actually the compounding interest formula. So that actually limit converges to the e. Okay, and e to the power x is a fastest growing equation. So there are some number of implications. For us, we are interested to only one thing, is that the Euler's number is approximately 2.71828. This is what we are interested in. So this is the probability of x. What is probability of x? Suppose you have modeled the coin toss. Okay, or here not a coin toss, but you can say that you have modeled where is frequency. Their frequency should be there, so that you can model the rainfall in a year. So in that case, you can ask that last year, suppose there were 300 rainfalls. Previous to that, there were only 200 rainfalls. You have collected the data for suppose 1000 years or 100 years, I might say. So 100 years data you have. Now you want to know the probability of getting 100 rainfalls this year. What is probability that I will get 100 rainfalls this year? Okay, or for the you have data for the railway station. Daily number of people are coming. Suppose there are 10,000 people are coming. Then next day there are 11,000. Then there are 15,000. Then there are 6,000. Okay. This data you have collected, number of people visiting the railway station daily. Then you can ask what is the probability of getting x is equal to 7,000 customers. Okay, 7k. Okay, what is the probability that I will get today 700 customers? That's what you can calculate. Okay, so x can be, this is the value which you want to predict. Then what is e? E is a constant, that is 2.71. okay, approximately. Then what is this minus since minus, what is this lambda? Lambda is what is the rate. So if you take average for this last 100 years, or if you take last 100 days number of people visiting here, so on an average, suppose average is 150 days on an average for last 100 years. Here you can check what is the average. Suppose here it is 10,000 people are visiting daily on an average. So that becomes your lambda. So lambda here it is coming, suppose I do this all in thousands, so here it will become 10. In case of rainfalls, it becomes 150. Okay, so this is my lambda. So lambda is just notation. No need to worry about notations. That what is the meaning of it, that is important. So it is just average rainfall, average number of people visiting, or in insurance case, average number of claims. Then same lambda power x. X is what you want to achieve. What is it? 100 divided by the x factorial. Factorial, you know that x factorial. Suppose 10 factorial is that 10 into 9 into 8 into up to the 1. Okay. So this is what the formula. Right now you just remember it. Just grasp what are the components. I will share this PDF with you so that you can understand and try using this formula. Okay. So now we will not directly go into the Excel practical. We will wait for some time, because we will finish our presentation and then we will go to the practical. Okay. So now Poisson distribution we are going to implement in reality. So what we are going to do, you are having problem. Suppose you are the manager of a FPO operating in Anand district in Gujarat. I don't know it's really in Gujarat or district or not, in Gujarat or not. So it is Anand district in Gujarat, and suppose you have 1 lakh farmers registered as a primary stakeholders. Okay, until this there is background. Now what is problem? You want to alert the farmers, those who are farming on the banks of river, about the flood. There are some farmers out of this 1 lakh doing the agriculture on the banks of the riverside. On the riverside they are doing. For that you have collected the data of flood from gazetteer for last 100 years. Okay, and you know that last 100 years there are 57 times flood has occurred in the district. So in this district there is flood has occurred for 57 times. So now you want to take the responsibility that what you will inform to the farmers about this flood. What you are going to inform. Whether you are going to tell that don't do the agriculture nearby the river banks because there is possibility of flood, or you are going to say that no, you can't do the agriculture, there is no possibility of flood. This is what you are going to do. So we will try to do this by hand. So now here, probability of getting, suppose in year, next year, what is probability of getting only one flood? Okay. So now we will try to calculate. What was our formula? Our formula was e to the power minus lambda into lambda power x divided by x factorial. So if you solve some 10 to 15 problems, then you eventually you will also remember this formula. Okay, I will just re-verify e to the power minus lambda, lambda power x. Yes. So this is our formula. What is the value of e? E is 2.71828. Okay. To the power, what is lambda? Lambda is here that on an average every year how many floods are there. So now for year you can get to the 57 divided by 100, which is equal to 0.57. Okay. So you can raise to the minus 57 into lambda, which is 57 to the raise 1 divided by x factorial, which is 1 factorial, which is only 1. So no need to calculate that. Okay. So you can plug these values in a calculator and you can get the answer, because I don't know how to calculate minus 57 times. Okay, raised to the minus 57, but you can do it very easily. So without going into the operation, what are the possible outcomes, what is the sample space, then you can, there how many values are getting. So 57, you cannot say that this is the probability, because we are talking about the population and population follows some pattern, so that this probability won't work over there. Okay, you need to identify the population parameters. Okay, so we will try to calculate these also in the Excel part, and you can verify with your calculator how much value is getting. We will calculate in the Excel that whether we are getting the same value or not. Okay, then we will look at the very important distribution called normal distribution. See, so far we have seen three distributions: the discrete uniform distribution, or we can simply say that uniform distribution. This is the discrete random variable or discrete probability distribution. Binomial distribution is also discrete distribution, and Poisson is also discrete probability distribution. But we are going to see now the normal distribution, which is the continuous distribution. What do I mean by? Suppose you are taking the values, like if you are going to study about the number of floods in a year, is it a continuous variable or it is a discrete variable? Pause a minute, think about it, give the answer. Number of floods in a year, this is your variable, and you have collected data for 100 years. What is the variable type? It is continuous or discrete? Yes. Okay, so I hope that you have got the answer. So it is the discrete variable, because it can take values only either 0 flood, 1 flood, 2 flood, 3 flood, 5 flood. Okay, it is infinite but countable. Okay, what do you mean by continuous? Continuous is that there between the interval you can take any value like 0.1112. Can this variable take this value? No, there are only some, you can separate it. There are some compartments. This is called the discrete variable. This is continuous variable. So if you take the example of the temperature, So temperature is the continuous. It can have 32.2, 32.2.2.23, like that values it can take. If you have the precision in your measurements, if you precisely measure, your apparatus or your instrument, as accurate it is, that much accuracy it can take the value. Okay. So your weight also you can take up to the infinitely many uh, precision to the decimal points. Okay. So that becomes your continuous random variable. In those continuous random variables, we can apply the normal distribution. Okay. So what is normal distribution? These are the characteristics we will see later, but where we can apply, like heights. If you collect your heights and you do this example, like suppose you collect the height of all 100 people from a group and try to plot these heights. Okay. And you see that what is the curve, or the what is the graph you are getting. If you collect the weights for 100 people, you can do that. Also the test scores, although test scores is discrete, you can also uh, model it as a normal distribution, because you can approximate it as a normal distribution. Errors in measurement you can also model as a often follows the normal distribution wherever you are doing some kind of measurement. That's what I'm trying to say. If you want to do some kind of measurement, like here you are measuring the score, you are measuring the error, suppose you are doing the heights, weights, so in that case it follows the distribution. Even the stock prices, interest rates, economic indicators. Okay. So these follow the normal. What is normal distribution? If you check the uh, icon of our group, this is the bell shaped curve, is known as the normal distribution. So it has the symmetry. If you check that, if you draw, this is the line where all 3 points like mean, mode and median are the same, fall on the same point. Then it has symmetry. This part is equal to the, almost equal to the this part. Then it has the standard deviation 1 and mean 0. It has average of 0 and standard deviation of 1. How is this possible? Can every data set have mean 0? Can you do some changes to get the average 0? Yes, you can do it. So how to do that? So that is what you can find on the internet. I will just simply give a clue that if you minus the mean from each observation, you can be able to achieve that. Okay. Why this is happening? Because you just want to shift this graph to the 0. So you want this graph, same graph on here. This is my drawing is not same, but what I'm saying, that this same graph you want to draw here. So this is what just you want to move it. I will just give you a demonstration also that how we can do that. Okay. And the standard deviation is the distance. This is the standard deviation is about the of the standard normal distribution and not the one. Okay. So these are the some values. Now we will look at the normal distribution formula. Just one thing to remember. See, we have said earlier, this is the continuous random variable. In case of continuous random variables, we are not having the PMF. PMF is only for discrete random variables. Here we have the PDF. What is PDF? It is probability density function. Why this is happening so? By theory, suppose if you have this line shape of curve, I will take a discrete also. In case of the discrete, you might have like this. Suppose it is uniform random distribution, you might have like this. This is the value. What is the value? Suppose it is taking only value 0, 1 and 2. This is male, female, another. There is probability of getting it as a 0.4, this is 0.6, and this is so this is 0.5 and this is 0.1. I have not drawn correctly. It should be like this. So don't worry about it. This is what I'm saying. But in this case, you have all the values from 0 to 2. You can take, suppose you are measuring the scores from 0 to 100, measuring the age with days and hours and minutes, age, because this is time. In that case, it is 0 to 100. Any value you can have. You can have the 1, you can have the 1.1.1 very very close to the 1, or you can have the 2 very close to the 2.1.1, very similar, very very on that case. In that case, you don't have the, for any value, suppose you take the PDF, in that case you need to do the what is called as integration. So what is the probability that you will get this value here? I will just try to change my color, maybe blue will be visible. So this value, the probability of getting this value is actually 0 by theory. Why? Because see, if you want to know the mathematics behind it, you need to know the integration in the calculus, how to integrate this function to get the area under this curve. I will not also claim that I am the master in that. But if you want to study really well in the statistics, then you need to know the probability, the calculus mainly. This is what we have not studied, and like my understanding is that in social sector you will not need this much mathematics. Just if you know this function or the formula, you can able to do that. And that's why little bit this formula is looking some crazy, but don't worry about it. I will just decompose it so that you will get what is that. So what is the f of x is equal to 1 divided by, this is the standard deviation of population, this is population standard deviation, into, this is into under square root 2 pi. Another constant here, the pi is, here it has given the value 3.14, we are taking normally. These all calculations you are going to do into the your calculator or your Excel. So don't worry about it, just you need to understand the formula. E to the power, this is whole is going to the e to the power minus into e is another constant, Euler's constant we have seen, e is 2.17828 minus mu is the mean of a, or also we can say the sample, raised to the square divided by 2 into standard deviation square. Okay, this is some complicated looking formula. Just don't worry much about it because the concept is more important. This is what formula, if you draw this formula, if you plot this formula, you are going to get this curve. Okay, and then you can have your range, you can fix this. For this, what are the variables? There are only two variables. If you check this formula, what are the variables? This standard deviation of population you want to know, and the mean you want to know. Okay, these are the two variables instead of your input. Okay, if you know these two variables, you can draw this curve. Once you know this curve, you can plug the value. Like suppose I plug here value 10, and I will get the probability of getting that value. Okay, so what does this mean by? If you know that the standard deviation is something x and mean mu of the height, you can say that what is probability that if I select a randomly selected person have height 5 feet, so that you can plug this value. So x becomes the 5. If you are collected whole data in the feet, what is the standard population distribution? Suppose it is 2 feet population standard deviation into under square root of root 2 into pi e to the power minus x will become again 5 minus on the average, suppose it is 6, average of the 6 feet. So minus 5 minus 6 will become 1, square becomes 1, 2 to the sigma square, so it becomes 2 into 2 square, so it becomes 8, e to the power 1 by 8. So if you plug this value, I will just calculate this for you. Suppose you know that standard deviation is equal to 2, the mean, or here I will write mu, is equal to what I said, 6, and you want to know the probability of getting, so probability of getting random selection person has height 5 feet is equal to, so you need not to collect now the data of your 1000 people. Okay, by that you have arrived some things over there, so that you can directly say that the probability of getting value 5 is equal to 1 divided by sigma. Now sigma is standard deviation, 2 into square root of 2 pi, I will not put values here, 2 pi into e to the power minus x, which is minus 5, minus 6, which is my mu, this mu, whole square divided by 2 to the sigma, which is 2 square. Okay, small, I'm writing very small, but what I have pronounced. So I can plug now these values into my calculator, and I can get the probability that I will get the height as a 5. Okay, so this is all about what we have did so far is about the normal distribution, and now we will move into the Excel practicals of getting the how we can implement this formulae into the Excel. And now here you will know that we have studied in our Excel part what are the things we have studied, how it is going to be helpful for us in the practical. Okay, so now we will just go to the our, yes, okay. So now this is the curve of the distribution. If you go and search on the Desmos normal distribution, this is what I have searched. So I will just try to do it once again for you. Okay, so now I am just I am going to search on the Google this Desmos normal distribution. Okay, Desmos normal distribution, and this is what the first result I have got. The first result is the normal distribution curve. Okay, you can do it by your own also, so that by you will learn the Desmos, but I don't think that there is now we don't have any need, there is such a need, but Desmos is very good tool, and it's open source now, at least free for us to do the graphing calculator. This is the graphing calculator. So this is the function. Now if you check this with our slides, so this is the formula, 1 divided by alpha, that is our standard deviation, into under square root 2 pi into e raised to the minus 1 pi. This is minus 1.5. If you remember, it was minus x minus mu. Here they have removed this minus, and 2 to the standard x whole square. So what they have did, 1 and here minus 1 and 2 have taken common, so it becomes minus 0.5. This is just algebraic manipulation and nothing else, and the whole to the square. So last time we have did very wrong. We have did here 1 square and there 1 square, but that will also should hold, but this is to the whole to the square. Okay, so this is not important. We not many times you are going to use this formula, but for your practice it will be helpful if you do some calculations on the this. So now this a is our standard deviation. So now you have known the descriptive statistics. So now you should know that how to interpret the standard deviation. So there is a question for you. You should pause the video and you should try to understand that what will happen if I increase the standard deviation. Okay, so now I have did it. So but you might understand that this distance, the distance of this curve from this main line, from zero line, this is symmetrical line, it is going to expand. This is what standard deviation we have interpreted. The standard deviation is something which is the distance between the mean, here mean is 0, and the values. As you increase the standard distribution, the distance between the mean and the values are going to increase. So now here it is, suppose this is very close to 3 and it is going to end. Now if you increase that, you see now it is gone up to the 5, here gone up to the 5. Okay, so this is what is the interpretation about the standard deviation. Now another important question, what will happen to this graph if I change the mean, if I increase the mean or decrease the mean, how this graph will change. So again you pause the video, try to find it that what will happen to the graph, and surprisingly if you just try to increase or decrease the mean, it is just going to change its position to the left and right. So that's what I said, getting the mean 0 is not a big deal. You need to just minus the mean from all your values so that it will become the it will come down to the zero mean distribution, because then some values will go to the minus, some values go to the plus, and if you take the mean it is going to be 0. Okay, so this is all about the normal distribution. We are I don't remember whether we have did something with the distribution or not. Okay, so we will just move to the our probability distribution practical. I think I am exceeding my time limit. Okay, but let it be, you can just watch it a little faster. Okay, okay, so now this is the this sheet I will share with you. So you now try to see what we can do with this some probability distribution. So now there is some data. Now this is the data which has been I have collected from, I think, Sajal's FWS2 data. So there are total 147 people, and I have just taken out only one variable, which is male and female. Okay, so in this case we can model this as a, you might know that this is, we can model as a binomial distribution. So this is what our revision part. So how to model this as a binomial distribution. So now I will model the female as a success. Female as a success, I will give value 1, and male as a value 0. Okay, so now from the, to model this, see I am now trying, the more important point is that I don't know about the population. Okay, so for now you just remember that this is about the sample. We are still have to go about the parameter estimation. So that means that what is happening with the population, that is more important thing. So we need to know the what is the rate of success about the population and how to estimate that. That is estimation problem. We will go to there, but for now your understanding, you can have up to here. We will calculate what is the probability of success. Probability of success is equal to, what is the probability of success? It is all the events occurring of female, how many times female is occurring here, divided by the total number. Total number we know, total number are 147. How to count the female population is equal to, we can use the count if formula, and count if we can select the whole range and we give the criteria as a female. Okay, but I did yes. So here I should not have the yes. This has happened because I used the exclamation or double inverted commas. Let it be. So I have selected the criteria as a female, and I have selected the whole range. So I will get that 73. So what is the probability that I will get the female? This is only 0.496. This is my probability. Now I am doing my experiment is that I am going randomly select the 10 people from this. Okay, and I want to know that what is the probability that I will get exactly two females. Okay, if I randomly go and meet to the 10 people randomly, whoever first comes to the temple, I'm going to meet that person. So I will go to the temple and just randomly watch who is coming the first, who is coming the second in that village. So what is the probability in this first 10 people there are only two females will come. Okay, how to do that? Now you know that what is our formula of probability binomial distribution. We know that now this variable is taking only two values, so that I can model this with a binomial distribution. What is the formula? That is n choose r, or it was n choose x. Okay, no, don't worry, if you are comfortable with n choose x, you do that. N choose r, you can do that. So don't worry about this formula. Important is that. Then what is that? The probability p of success raised to the power x. This is the symbol we use for raised to, because we cannot write this superscript. So this is p to the power x, and 1 minus p to the power n minus x. So now here, what is my n? N is number of trials. Okay, so what is my n? So I will write here, here n is equal to 10. I'm going to take 10 trials. What is my expected number of success? Success is my x, or as I have written everywhere x, so I will change here to the x. X is equal to 2. I want to get 2 success only. So now I am doing this as a raw mathematics, because you should know the formulas which you might remember, the arithmetic operations we have learned so rigorously, because only to know these statistical problems. So now how to do these combinations? Here very interesting formula called combine. Yes, so it's combine. And these also you can include the repetitions. So combine you can use. So number of combination from set of objects. So this is n choose k, or n choose x, or n choose r, whatever. So here n is 10. What is I am going to choose? 2. Okay, this 2. What is p to the raised to the x? What is my p? P is my this formula which I have calculated. So I will say here raise to, how to raise to the something. So we will use here power function. Or I think, yes, if you do this notation, yes, so this notation also will raise to the power. And we learned one function called power, or POW. POW is a very fancy one. This is the base, and this is my exponent is 2. Okay, this is my outcome. Now what is my 1 minus p raised to the n minus x? Again I will do my power function. 1 minus this formula, this is my base, and my exponent is n minus x, that is 10 minus 2. You can directly add 8. So now we will multiply just these three values to get the our. So this is this into this. So what is this probability? I am getting, what is the probability that I will get only 2 women out of 10. Okay, so if I change it to percentage, there is only 4.5 percentage chance that I will get exactly what I am saying, exactly 2 females. That is probability is here. Now tricky question for you, just try to solve. If you're not getting, you can call back to me, or you can use just on the group. What is the probability that I will get at most 4 women I will observe at most 4 women if I select 10 persons randomly. Okay, so you got my question. I'm randomly selecting 10 people, and in that case I want that what is the probability that at most max I will get the 4 women. Okay, the clue here is that you need to calculate the probability for what is getting 1 woman, what is getting of 2 men, exactly 1, exactly 2, exactly 3, exactly 4, and then you need to add up. Okay, so but you can try this on your own, then only you will get. So for your purpose I will just keep this as intact, and just I will show you that this is the raw one, but how to get this same calculation without using the formulas, without remembering. I always saying that you don't remember the formula, then you might ask that brother, how I'm going to get this answer without remembering this formula. Just simply you know that this is the binomial distribution because it is taking binary values, only 2 values it is taking. In that case I can model it as a binomial. So you can simply directly go and say binomial distribution. Okay, binomial distribution here, binomial dot dist formula is in Google Sheets. You can check for the similar in the Excel sheet. What is the number of success I want? I want 2 number of success. How many number of trials? 10 number of trials. What is the probability of success? Probability of success, I will just select this cell E5. Okay, E5, should it be cumulative? Cumulative in the sense of the continuous curve. Here we don't want, so we'll say this false. We don't want this. We'll just close it. Add up, and again I will format it for percentage just comprise, and these values are same. Okay, so you need not to do this all formulas and do the calculation. This is what, if you want to learn really the Excel part, you want to really decompose everything for your understanding, you can practice this. But for your just directly when you want to plug the values, it is just binomial distribution, and you will get the just you plug the values and you will get the answers. Okay, I did something. Okay, let it be. Okay, so now again we will move to the next sheet. Now here we will just go into the Poisson distribution problem. So what is the Poisson distribution problem? You saw that I given you the problem that there are, I have data of 100 years, and it has been observed that there are 57 floods for last 100 years, and I want to calculate in the next year, so 2025, what is the probability that I will get the flood. Okay, and for that we saw that we need to use the formula of Poisson distributions. We can model this as a Poisson distribution. First we will calculate the lambda. So what is our formula? E to the power minus lambda. I will just write a, or you can use the lamb function, minus lambda into lambda power x. Okay, divided by, I will just write divided by, so I will just common is here, merge it. Okay, x factorial, x was small, so x factorial okay. So this is my formula for my probability Poisson distribution. Lamb is that the continuously, or this is just mean or average, you can say that, so don't worry. So how to calculate this lambda? Lambda is just is equal to 57 floods on an average 100. So 0.57, this is my probability of success. Success is not mean positively here, but this is just flood is not positive thing. This is not success or something we are getting. But here in terms of the probability distribution, it is success. Okay. So now here we can plug the formula. I'll just check how to raise to the e. So it is some e x. Okay, x. So this is formula exp. So what is this formula? The Euler's number e raised to the power. So here we want to say what is exponent e to the power minus lambda. So I will say minus 1 into this part. Okay. So this become minus 1. So it will negatively create this formula. So this thing we have calculated as e to the power minus lambda. Lambda power to the x. We have seen the power function. So power. What is my lambda? Lambda. What is the power of x? So here is the x. What is my x probability of getting flood? We calculated for one flood. What is probability that I will get one flood in this year divided by x factorial. So what is that fact? It's a short form of factorial. Fact of 1. Okay, that is going to be 1. Now I will just simply do the calculations here. Is equal to this into this divided by this. Okay, and it is going to give me that 0.32. So that I will just change it to the percentage. It is 32% possibility that I will get one flood. But what is about the no flood? No flood means what? My variable should take the value 0. Okay, so p of 0 is equal to, now here what we will change? X value will change. What is the x value? X value is 0. So here we will change, it is not minus 1, here it will become minus 0. So minus 0 is no need, it is just 0. Oh sorry, this minus 1 is correct because minus 1 lambda. I will check lambda power x. So lambda power x will become power 0. Okay, and my factorial of become 1 to the 0. So now it has increased from 30 to 56.55%. If you remember what I have said, that it is not about the because you randomly you do normally, you should, if you do the normally with the sample survey, it will come to the 0.57, but I have did it as a Poisson distribution. That's why it is coming 56.55%. So this is how you will do if you want to do it in by hands or by your normally doing way of calculations. If you want to plug it by the formula, then you can do just Poisson distribution. What is my x? X is here. First we will take 1. What is my mean? Mean we will just take 0.57. Whether you want cumulative, no. So I will false. Cumulative is in terms of the continuous variables. Okay, if you have, that is different story. Just so this is giving me correctly 32.3. What is we have calculated? Now this is for the 0 success. So we will just change value to the success of 1 to the 0. And yes, I'll just convert percentage 56.55. Yes, here also we got the 56.55. Only one simple formula, Poisson distribution, and you will get the values. So that's it for today. We will just end up here, and we will meet with the next Saturday with maybe the sampling methods. What is the sampling, and we will see the relation between the population and sample, and then we can move into the parameter estimation, and then we will go to the hypothesis testing. So there is a long process here. Sorry for the delay for releasing today's lecture, but due to some problems it has happened. So okay, we will meet to the next Saturday. Thank you so much, and all the best.